Assalamu alaikum dear students. Today we will do AC analysis, in which especially we are going to discuss the small signal modeling, and this is the part 1 of our topic AC analysis. We have designed, biased an amplifier and observe its efficiency to amplify input AC signals. So we already know the basic idea of amplification by BJT, right? And today we are going to consider the computations about AC signal operation, especially for the small AC signal. We usually would be having small AC signals for amplification. So we have already designed past a BJT in active region because we want to design it for amplification, right? So amplifier design requires the biasing of the BJT in active region, and for active region we have to ensure the forward biasing of base to emitter junction and reverse biasing of collector base junction. And designing of it basically involves the finding of our biasing resistors at the base side, base emitter side basically, and resistors for collector emitter sides. Besides designing, selecting of VCC or user defined VCC. So we have already done all these things. And remember, we have done two examples of amplifier designing, one with RE and one without RE, right? So if RE there, you have to find RE as well. Otherwise, R1, R2, and RC, right? And an input AC signal V is injected through a coupling capacitor, right? For what? For amplification. And why with coupling capacitor? To avoid the disturbance of our biasing, right? So we have biased this signal with this DC-VCC and designed these parameters, so we are not requiring to disturb our biasing voltages and currents about this DC equivalent circuit, right? So when an input signal is injected through capacitor, then AC can comes here, and a total DC and AC parameter will be here at the transistor to behave as an amplifier, and the amplified signal, the AC signal, will be collected from through this capacitor, again to avoid disturbing the DC parameter here as well, right? So we have already observed this amplification besides learning all the designing of DC biasing, right? So now we are going to analyze how to computationally find the value of V out and V in to be considered while we are designing an amplifier, and also the basic amplification parameter gain, how we can set it. So what circuit the AC source can see? As we can see that this DC source can see these resistances, these and this all junctions, right? And cannot see this source as load because of this capacitor, right? So this capacitor behaves as open circuit for DC source. Same is the case for this capacitor, right? So how about this input signal, the AC input signal? What circuit it is seeing? We have to first see that, right? So it means we are going to find the AC equivalent circuit that this source is seeing. So capacitor behaves as short circuit, right, for AC signal. But remember, if the capacitor value is selected for the applied AC signal, for the desired AC frequency, right? We will discuss it later. But just remember that the XC of this capacitor is 1 upon 2 pi FC. So it means for a particular frequency, this capacitance is designed, then it will behave as short circuit for that frequency of the input signal, right? We will deal with frequency related computations later. And how about the DC supply? So the DC voltage supply appears as ground circuit. This will behave as ground circuited. So it means this capture, this AC signal through this capture can see these parameters, but not this voltage source. In fact, for this input AC signal, this terminal is behaving as a signal ground, right? And how about DC current supply? If we are not having a current source here, but if we would be having a DC current supply or DC current source, it appears as an open circuit. Now let's see the AC equivalent circuit of this amplifier, the circuit which this source is going to see. So we will call it an AC equivalent circuit. The DC equivalent circuit was this, right? The capacitors becomes open circuited, right? But now capacitors become short circuited. DC voltage sources behaves as ground circuited, and if there is any DC current supply, it appears as open circuit. So you can see we have to put a ground here for an AC equivalent circuit. We have to put a short circuit here for the capacitor if designed for the frequency of the input signal. Also at this capacitor, right? So this is what the circuit is being watched by this input AC signal. And why is it so that this DC supply is looking like a ground? And same would be the case for the DC current source. It is because the DC source tries to hold a constant signal, right? So it means if we have this a 15 volt or 16 volt supply, let's see, for example, then this DC supply will try to maintain a 15 or 16 volt DC signal here, besides providing the DC voltages and DC currents to these components, right? So now what this AC signal can do is this AC signal is added to the parameters of these components, the voltages and the currents, right? So then this circuit will behave for the total voltages and currents about these parameters, right? The DC and AC both will be added to have a total current or voltage, right? So the AC signal will try to do the same thing at this terminal as well, right? But this supply will maintain a constant DC voltage here, right? So then no variations here. It tried to insert variations and no variations here. It means this terminal is behaving as a signal reference or zero signal for this input AC signal, right? So that is why we have, or actually this signal can see only a reference ground, a zero signal as far as the variations are concerned. So same will be the case for DC current source if we would be having one, right?